we talked about how you can use relative frequency also as part of your histogram to come up with them. And then remember the last part, we had talked about the relative frequency density to kind of help us come up with, a better representation of our data. And this was kind of the example we had looked at. Of course, you can have histograms where you just have single values in your distribution, right? So instead of having those classes with the upper limit and the lower limit, even if you have single values, you are still able to create a histogram based on that. So that's kind of what this example goes over. So this is, I think, talking about a sample of high school seniors were asked, how many television sets are in your house? And then based on their answers, you can see we can go anywhere from 0 television to 5 TVs, in your house. And then they're showing us the frequency of how many students had, how many TVs in their house. So based on that, we calculated our, total for the frequency column. So it looks like there were 50 students in this class. We calculated the relative frequency. And then based on that, we can go ahead and create our histogram. So you can see 36% or 0.36, of the students basically had 2 television sets in their house. Only 2% or 0.02 had, 5 TVs in their house. So you can kind of see how, visualizing the data can help us out. So histograms can be for grouped data, but histogram can also be used for single data values like we saw in this example. Now, one of the other representations, graphical representations that we use is, a pie chart. So this one mainly can be used for something like categorical data. So, if we wanted to ask students, again, we'll just use students, the reasons for why they were running late. So if you gather that data, then, you can use a pie chart for that, because in this case, it's more about, the reason for them running late instead of numerical value. So that's kind of what we're saying. For studies that involve categorical data, we can use pie charts to show that representation. So what happens in a pie chart is basically, you're taking your 100% of the data and you're breaking it down into, how much of our data is, part of this category. So how much can you break it down into? And then each slice of your pie chart, kind of thing like a pizza. Each slice of your pie chart, the size will depend on, what percentage was assigned to that. So how many data values fell under that category. And then since we use a circle to represent a pie chart, we of course have to then think about corresponding what our percentage would be and breaking those 360 degrees down based on, what each category will be. So this graph over here that you're seeing is basically talking about how a typical medical dollar is spent. So you can see the biggest chunk of this pie chart is, if you're taking $1, that is the same as 100 cents. So we're taking those 100 cents and breaking them down. So you can see they're saying 39 cents are going towards, doctors. 29 cents are going to the hospitals for overnight stays, same day surgery. We're talking about 12 cents out of that will go to your HMO administration. 9 cents are going towards drugs, any prescribed therapy would be 7 cents. And then the remaining 4 cents would be going towards, convalescent care, home health care, medical equipment. So they're just kind of showing you, how this dollar that you spend on medical expenses, how they are being, billed, basically how it's being separated. So here's an example talking about what type of academic degree do you hope to earn? So again, you can see this is a categorical type of question because they're asking you what type of degree, the student is expecting to earn. So you can see our different categories are associates, bachelor's, master's, and a doctorate, right? So 4 different categories. So here's the data that we have. They're saying the different types of degrees and the number of each type of degree confirmed in the United States during the 2010-2011 academic year is given below. So you can see we had a total of 3,553 degrees that were, conferred upon students in that year. So now how do we break this down into a pie chart? So you would take, each of these frequency values that you have for each of the categories, and you're basically calculating a relative frequency, because that tells you, what percentage of the pie goes to that category. So you can see we take our 942 divided by the 3,553, and that gives us a value of 0.265. And we're repeating that same process for all the remaining three categories. And again, since you are converting this into decimals, your total has to be 1. I know it says 1,000 here, but that's a typo. It should basically just say 1.000. So it's just a typo with the comma. Because again, remember, if this was in percentage, it would add up to 100%. With the decimal, it adds up to 1. Once you calculate the relative frequency, then we need to figure out what the angle or what portion of the circle is being assigned to that category. So basically, we need to know the angle of the circle. And since we know a circle has 360 degrees, you take each one of these relative frequency values and you multiply it by 360. So you can see the associate's degree category is going to be 95.40 degrees, so that's the portion of the circle that goes to that. Our bachelor's degree had the largest frequency. So of course, it also has the largest relative frequency, which means it will also have the largest angle measurement on it. So repeat that same process for all 4 of these categories. And, of course, all of these degrees should add up to 360 degrees, because you should get a full circle out of that. And then, if you're drawing by hand, then, of course, we need a compass, we need a protractor and all of those things to help us come up with these angles. But once you get that set up, I mean, you can see again, the biggest chunk of our pie chart goes to our bachelor's degree, because we know that's where we had the highest frequency, and that's where you had the highest relative frequency also. So that's approximately 48.3% of these 3,500 students who got a bachelor's degree in the year 2010-2011. After that, we had associate's degree at 26.5%, master's degree at 20.6%, and a small chunk compared to that of 4.6 who got their PhDs, right? Who got their doctorate. So that's kind of the idea behind constructing a pie chart. Now, you guys are, of course, not drawing a pie chart, but you will, go through these calculations over here for, the angle, the relative frequency, and that kind of thing. So I think with the pie graph, you actually select out of, options given to you. So you're not actually drawing that. You're just selecting the right graph and then, just go through those calculations. And then, of course, there are many, many other types of graphs we can use. We use bar graphs. We use line graphs. If you look at time series graph, we use those. Even in bar graphs, you can have, histogram is technically a type of a bar graph, but then you can have a horizontal or a vertical bar graph. We have something called as a Pareto chart, which is also bar graphs, but the only difference with the Pareto chart is it goes in order from the highest to the lowest. So you can see, like with the histogram, we have no order. We started with 4%, then jumped up to 26 and 36%, because we went in order of our table. But with the Pareto chart, you would start with the tallest bar and then go down to the shortest one. So, in a Pareto, the 36% would have been at the left, then 26%, then 22%. So you go down in order. So like I said, there are many, many different types of graphs that you can use. We're just kind of looking at histograms and pie charts over here. All right, guys, so that was section 4.1. Now we're getting into a little bit more calculations with our data. So we're getting into measures of central tendency. So when we talk about measures of central tendency, we're really talking about averages. So when you're trying to find the average of your data, now average is actually a generic term. average can be 4 different calculations that we can do to find these measures of central tendency. Now, your textbook is only talking about 3 of them, but I will mention the 4th one to you also, so you're at least familiar with the terminology. So we have mean, which is what we also call as the arithmetic mean. So this is where, you add all your data values and divide it by how many values you had total. So that's your mean, which is what we normally think about as an average, right? Just add everything together and then divide by how many ever data values you had. We have median, which is actually the position. So if you arrange your data from smallest to largest, then you find the centermost position, and that's your median. When we talk about mode, we're actually talking about the most typical value, or in this case, you can think of it as the value that has the highest frequency. So the mode is which number occurs the most often. And then you have a 4th one, like I said, they don't mention that in your book over here, but a 4th one, which is what we call as a mid-range. And the mid-range is where you take your highest data value, add it with your lowest data value, and then you divide it by 2, and that gives you your mid-range. So there's actually 4 different calculations that you can use for averages. So like here, if you look at some of these questions they're asking, they're saying, who is the best running back in professional football? That's going to be a calculation based on average. How much does a typical house cost? What is the most popular television program? So these questions may not seem like, we're talking about averages, but basically that's what they are. They're all going to be based on averages. So let's look at some of these calculations over here. So like I said, with your mean, sometimes it's also called as the arithmetic mean. So this is where you add, all your data values together and then divide by how many total values you have. So as a formula, we can write it out like this. This symbol that you are seeing is the Greek symbol for sigma as a capital letter, but this in math, we use this as a summation symbol. So that means you are adding. So when you see that summation of x on the numerator, we're saying add all the x values together and then divide by n, which is how many data values you have in your sample or your population. So actually, the example we were looking at last time, if we had to calculate, the average for this, and I'm actually going to go over to our page over here where we had sorted this out, in order from smallest to largest. So the idea is if I wanted to add all of these values together and then get my average, and for now, just to keep it simple, we'll do just for the 1 year, and we'll just take 12 out of those 24 values. So the idea is if we were trying to find the average for candy production in this year 1972, then all we would have to do is add these 12 numbers and then divide by 12, because we have 12 data values. So if we were doing this by hand, then of course we would take 97, add 101 plus 101, 102, 102, 103, 104, 105, 107, and then the 2 108s. You would have to add all of them. If you're using something like Excel or Google Sheets, they actually give you a sum function. So SUM, and actually, I think this has to be capital. And then we can select those 12 values. So that makes it a little bit easier for us to add them. So if you add this by hand, obviously you should get the same value. So now when I want to find, the mean for this, all I will do is take the total for all of those 12 values and divide it by how many data values I had. And, of course, I've got 12 in here. So you can see our mean will come out to be 103 point, 41666666 repeating. So that would be your basic idea behind calculating the mean. And again, you've got a couple different examples in here to help you out with that. One thing I want to mention about this example, because I think you have a homework problem that's similar to this guy. So this might be a good example to come back and look at when you work through homework. But this one is asking you to find the mean finishing time of Tony Cannon's, Indy 500 outings. And then the second example is what's his average speed. So here you can see they're telling us, he won the 2013 Indy 500 race. He set a track record. He finished the 50-mile race in a record time of 2 hours, 40 minutes, and 3.4181 seconds. And then they have, his finishing times over 4 different years over here. So you can see what those times are. Now, to be able to find, what his mean finishing time is, since you're given the time in hours, minutes, and seconds, you actually have to convert your time before you can even start adding them. So you will see we are taking our hours and we're converting it into minutes. We're taking the seconds and we're also converting them into minutes. And, of course, minutes are staying the same because we are basically converting the time into minutes as the first part. So for all 4 of these times, we would be taking the hours, multiply by 60 to convert them into minutes. You take the seconds, divide them by 60 to convert them into minutes, and then add all of those times together. And, you get the finishing time for all 4 of the years in just minutes. And you will see once you're done with that calculation, we can rewrite the time in minutes, and then you can go ahead and add all the minutes together, divide by 4 for the 4 years, and we end up getting our mean value. And again, remember, we use the X bar as our symbol, our notation for talking about mean. So that's going to be the X bar. And once you have all of them into minutes, it becomes easy. So remember that, and that's kind of one of those general rules of math, is when you're trying to add quantities together, they have to be in the same unit of measurement. So if you had something in feet and inches, you would need to convert everything either in feet or in inches, depending on, which would be easier to do. With time, you can see you had hours, minutes, and seconds. So we're converting everything into minutes. So keep that in mind. You have to have one unit of measurement. You cannot do feet and inches at the same time. So that conversion will be something you will have to do. And then once you have, your numbers taken care of, then you can go ahead and perform your operations for mean, like we saw in this example. And then they just go through the example of how they came up and found his average speed over here. So you will see they were talking about, for that 2013 Indy 500 victory, what average speed did he have? So, of course, we know it's called Indy 500 because it's a 500-mile race. So you've got the 500-mile race. We've got his time in minutes now. So you're basically, if you're converting, because we're talking about average speed in miles per hour, so you can see we take the 500 miles for the track, how long the race is. We've got his winning time, right? The 160.057 minutes. That's how long it took him to go over the whole race. But this is miles per minute right now, because you can see we're taking miles and we're dividing by minutes. Our average speed is in miles per hour. So that's why we're multiplying this with 60 minutes over 1 hour, because we are converting our minutes into hours. So that's what we're doing over here. And then once you simplify this, you get your average speed. So he was going on an average, at a speed of 187.4 miles per hour to get his winning speed, to get his race completed. So this will be something, and if this is a calculation you have not done in a long while, this is what we call as dimensional analysis. And what that basically means is you can see we had miles per minute to start out with. We need to convert this into miles per hour. So you need to get rid of those minutes on the denominator. And so you can see when we set up this conversion factor, we put minutes on the top and we put hour on the bottom, because just like we do with any fractions, same thing happens with your unit of measurements. Your minute and minute cancel out, leaving you with miles on the top, hour on the bottom, and that's how we got our miles per hour. So same thing happened when we were converting these hours into minutes. You can see you have 2 hours, and we can write that down as 2 divided by 1. So again, what's happening is the hours is canceling out, and you were left with 2 times 60, which gave us the 120 minutes. We kept the 40 minutes as it is. We didn't need to convert that. Now with the seconds, same thing is happening. You've got seconds on the top, seconds on the bottom, so they cancel out. And then you end up taking 3.4181, dividing it by 60, so that we can convert our seconds into minutes. And that's what this comes out to be. So 3.4181 divided by 60 gives you the 0.05, 696833333. So whichever unit you want to keep is what stays here on the top. Whichever unit you want to get rid of, that's what's canceling out, from these two sides. However, in our miles per hour, we wanted to keep the hour, and we knew miles per hour means the hour has to go on the denominator. So that means the minutes were going to cancel out, and that's how we set it up. So that's what we call, like I said, as dimensional analysis, when you're doing these conversions, going from one unit to the other. So again, you've got different examples here showing you how, if you had a grouped data, how you would find the mean. And this one over here, are they giving us that terminology? Yeah. So you actually have to find the midpoint for each interval before you can actually calculate what your mean is going to be. So you can see they're actually taking the upper limit, lower limit, and the upper limit, adding them together, and then dividing by 2, which gives you the midpoint for the first interval. You will repeat that same process, for all of the other intervals. And do they show that over here? Yeah. So you can see we take 16 plus 20 divide by 2. It gives us the midpoint of 18. 20 plus 25 divided by 2 will give us a midpoint of 22.5. So you repeat that same process for all the intervals, right? Get your midpoint, and then we multiply our frequency with the midpoint to actually, you can see this is F times X. This is our F column. This is our X column. So we multiply the frequencies with the midpoint, get a total for that column, and then you divide it by what was the total of your frequency column. So this is the calculation that I actually want to look at, because this might be something you may or may not have done before. So what example did I have over here? Okay, let's look at our textbook for this guy. So you've got some basic examples at the beginning just to kind of help you get comfortable with the mean, median, mode calculation. So you will see these are all going to be single data values. Some of them are decimal, some of them are whole numbers. So you will have some examples like this in your homework. But like I said, I wanted to look at the group ones because that is something that's probably going to be new for us to look at. So let's start with number There we go, number 18 over here. Okay, so you can see this one is saying, to study the efficiency of its new price scanning equipment, a local supermarket monitored the amount of time its customers had to wait in line. The frequency distribution in figure 4.64 summarizes the findings, and they're saying find the mean amount of time spent in the line. So you can see it's showing us on the left-hand side, how much time the customer spent in line and how many customers had to spend, less than 1 minute to 2 minutes, and that kind of thing. So the first thing we will do is start out by finding our midpoint for each one of these intervals. So okay, let's create an extension to this table. So for the midpoint, remember again, you're adding the lowest data value with the the lower limit with the upper limit, and then dividing by 2. So like in the first category, we will be adding, and I guess I'm going to do that here, 0 plus 1 divide by 2. For the second interval, we will be doing 1 plus 2 divide by 2. So you get the idea. And we'll need to do that for all 5 of these intervals. So go ahead and calculate your midpoints and then tell me what those 5 numbers should be. So finding the midpoint for each one of the intervals. And I would say let's leave them as decimals, because I have a feeling we're going to get fractions as our answer for most of these. So we can go ahead and convert them to decimal. So as always, I'll have you guys share your answer through the chat. Just get your answers ready, and then I'll have you guys share. And again, you can just use a comma to separate your 5 answers. All right, let's see those answers, guys. All righty, very nice. So I am looking at 0.5, 1.5, 2.5, 3.5, 4.5. That was Ethan. Nicholas, looks like you have the same thing. Okay, Brandon, looks like you had 0.5, 1.5, 3.55, and 6.5. Well, our numbers went only up to 5, so you really shouldn't have a 6.5 in there, or for that matter, 5.5. Logan, you've got 0.5, 1, 2, 3, 4. Okay, same as Ethan and Nicholas. Roman, same thing it looks like. And then looks like Cynthia, you also came up with 6.5 with yours. So 0 0.5, 2, 3.55, 6.5. Okay. So a couple of you have larger answers. So this guy definitely adds up to 1/2. 0 plus 1, of course, is 1. So that's 1/2, which gave us the 0 0.5. The 2 plus 1 would be 3. So that's 3/2, which comes out to be 1.5. 2 plus 3 is 5. So 5 divided by 2 is 2.5. 3 plus 4 will be 7. 7 divided by 2 is 3.5. And then 4 plus 5 is 9. 9 divided by 2 is 4.5. So I would say it's probably just either a typing error or something. Okay, yeah, Brendan, that's kind of what I'm saying, that either you just mistyped something in your calculator. So I would say just, make sure you check your math to just be sure that you're on the right track. So that's your first step on finding the mean when you have a grouped distribution like this. So start by finding your midpoint. Now, where they're telling you number of customers, that's basically your frequency column. So that means for the next step, you are multiplying the frequency with the midpoint. So basically, these two columns, you are now going to multiply them. So let's see, what will this come out to be? So let's start again in order from the first one. You're multiplying 79 with 0.5. So, of course, you're just taking half of 79, which will come out to be 39.5. You are taking 58 times 1.5, which will give us 87. 64 times 2.5 will be 160. 40 will be multiplied with 3.5. So that guy goes up to 140. And then 35 times 4.5 will be 157.5. So that's multiplying the two columns. Now we need to get the total of this column. So let me see what this total comes out to be, guys. For our F times M column. And while you're at it, we will actually also need the total for our customers column. So F times M, what does that total come out to be? And then how many customers do we have? So get those two answers ready. I'll give you guys a little bit more time to add up the frequency column. Okay, let's see those answers if you have them. All right, Brandon, you've got 584 for the frequency times midpoint and total of 276 customers. Nicholas, 584, 276. Roman, 584, 276. Okay, so looks like similar answers from the three of you. Ethan, 584, 276. Okay, Cynthia, 584, 276. Okay, all right, very nice. So the total for our frequency times midpoint 584, and that's what I came up with. And then you had 276 for the customers. So those are actually the numbers that we were trying to get to. So remember, for our mean, for group data like this, if I had to, rewrite the formula, that would be the total of the F times M column, and then divided by basically the summation of just the frequency column. So that is our 584 divided by 276. And what kind of average time are we looking at here? How long did the people have to wait in line? So Brandon, you've got 2.115 or 2.1. And I didn't see instructions for rounding. Yeah, I don't think they really tell us. So yeah, we can keep it at 1 or 2 decimal places. And then, of course, in your homework, they will definitely give you a rounding, option. So, in your homework, you will definitely have something there. So let's take a look at this. I've got 2 more answers over here. It's 1 decimal place. Okay, Brendan, good to know. Alrighty, so let's just check that answer. So you're taking 584, dividing it by 276. So you had 2.1159. And, of course, this number keeps going. So if Brandon is saying homework wants 1 decimal place, we'll just do 1 decimal place for now. Ethan, you got 21.1, or did you just mistype the decimal? Okay. Alrighty, and this is of course time in minutes. So we are saying on an average, the mean time spent in line is going to be 2.1 minutes, which is not too bad. If you're standing in the checkout line for only 2.1 minutes, I mean, realistically, depending on some of the stores you visit, it definitely can be a lot longer than 2 minutes. So that's kind of the idea with grouped data, how you find the mean. So did anybody have questions on this example here? Okay, let's save that. And your textbook actually is still calling the denominator an n, but just remember that n is the total of the frequency column, okay? So that's the formula over here. Okay, let's get into median. Now, as I was telling you earlier, the median is more about a position, where the center of your data will fall. So in this case, as you can see, they're talking about, and one example, and I wonder if this one has it. Yeah, so it's saying, think about the word median is also used to describe the strip, that runs down the middle of a freeway. So that's halfway, between your freeways. So half of the freeway is on one side and the other half is on the other side. So if you think of that, that's exactly what we mean by the median. Half of your data should be towards the left of the median, and half of your data has to be towards the right. So they're saying the location of the median can be found by using this formula, n plus 1 divided by 2. But before you use the formula, just make sure your data has been arranged from smallest to largest. So going back to our candy production example over here, again, just using these 12 values for now. You can see, since we've already got it arranged in order, and these are 12, data values. So that means we have to separate them by, 6 and 6. So if you use the n+1 divided by 2 over here, let's do that over here. So if we did n+1 divided by 2, well, we've got a total of 12 data values. So to that we add 1 and then divided by 2. So that's technically 13 divided by 2, right? Which will give us 6.5. So what the 6.5 is telling us that we will find our median in the 6th and the 7th position. So when you have an even number of data values, you will actually get two numbers which are going to be in the centermost position, and then you actually add them and divide by 2 to find what your median is going to be. So for our median calculation, if you start at the top, that's going to be the first one. So that's 1, 2, 3, 4, 5, 6, and 7. So you can see in the 6th and the 7th position, we have 103. Even if you start counting from the bottom, it should be the same two numbers. So if you think of 108 as being the first number, so that's 1, 2, 3, 4, 5, 6, and 7. You will see again, we land back at 103 and 103. Now in this example, it happens to be the same number, but obviously that's not going to be true for all of them. So for our median, what you have to do, like I said, is add the numbers in those two positions and then take its average. So divide by 2. And of course, in this case, we know it's going to come out to be 103 because you're adding the same number. But let's say if it was 103 and 104 in the 6th and 7th position, then your answer would have come out to be 103.5. So if you have an even number of data values, then you will have to take the two centermost numbers that you have in there and then take its average to find the median. So again, let's see if we can just do a quick example from our textbook over here. Trying to see if I can find something with an odd number of data sets. It seems like most of them have an even number. Yeah, most of them have even numbers, but I guess we'll just use one of these just to make sure you guys are getting a little practice. Let's look at number I guess we'll do, I don't know, let's do number 8. You've got the part B with the larger number. So let's take this guy into account. And we're looking to find the median for this. So here you've got 600, 800, 1000, 1200, 1400, 1600. You can see they're already arranged in order for us from the smallest to the largest. So use your position formula or location, as your textbook calls it, to find the location where your median will be, and then based on that, calculate your median. So the answer I am looking for is the median from you guys. So, take a couple minutes, find the location, and then based on that, calculate your median. And then we'll have everybody share their answers. Since it's only 6 values in your data set, of course, it shouldn't take you too long to find the two centermost values. Okay, so what did you have? Okay, Logan, Brandon, Ethan, Roman. So, like I said, you have Cynthia already. We've got 1, 2, 3, 4, 5, 6. 6 plus 1 would be 7. And then 7 divided by 2 is, of course, 3.5, which means you are looking at the third and the fourth position. So either direction, the third and the fourth position is going to be these two numbers. So 1,000 and 1,200. So you're basically taking 1,000, adding 1,200 to that, and then dividing it by 2, which of course will end up giving us, what is that, 2,200 divided by 2, and that's where your 1,100 will come from. And this is going to be our median. Alrighty, very nice. Nicely done, guys. Any questions on this? Okay. Okay, so I think this part A actually has odd number of data values in here. So you can see we only have 7 data values here. So when you use that position formula, it will give you just one number, not a decimal, right? A whole number. So that means you're just looking for the fourth position. So put these in order. And once we arrange this in order, you can see 1, 2, 3, 4 from either direction will bring us to number 6. So then 6 becomes our median. So this is when you have an odd number of data values. Now, when you have an even number, so in part B, you can see we have 8 data values. So in this case, then of course, when you find your position, that's 4.5. So that's going to be between the fourth and the fifth position. And so fourth and fifth will be 6 and 8. So which is kind of what we have had, happen in our example. So then you find your median, which comes out to be 7. So just depending on if you have an odd or even number of data values. So you can kind of look through that. Here was a nice example that your textbook had featured, about this average income for doctors. So you can kind of see how they're talking about using the average and the median net income figures to kind of show you based on, which specialty the doctor is in, what their average, and they're using average in terms of, the mean. So usually as mathematicians and statisticians, we don't really like the word average if you're talking about the mean, because remember, average is the word we use for any 4 of these calculations: mean, median, mode, and mid-range. So if you want to be specific, you actually want to say mean, or at least arithmetic mean, and not just call it an average. But in just English, a lot of people just think of mean as the word average. So sometimes it can get a little confusing. But when they're talking about the average here, they're talking about the mean, and then we have the median income. So you can kind of see when they do the 2 different calculations, how different these 2 numbers are looking based on which calculation, they used. And so sometimes you will see in statistics, we ask the question of, well, which measurement is more appropriate then? Because, sometimes if you have doctors who are making like absurd amount of money, then they will take the mean to a higher number, because if they have a really large income, then they're going to bring that average higher up, so that mean will end up going up. So sometimes the median might be a better indicator of, the average than just using the mean. So, sometimes it just kind of depends on which calculation might be more appropriate to represent the data you are looking at. Here they're talking about how you can find the median when you are looking at a frequency distribution. So in this case, we're talking about the students as Miss Carlos' art class were asked how many siblings they had. And then here's the frequency. So 2 students said they had no siblings, 5 of them said they had 2 siblings, and that kind of thing. So in this case, they're saying, of course, we can go ahead and arrange these in order. So, we've got 2 students at 0, so that's 2 zeros. Then we've got 8 students who had just 1 sibling. So you would go ahead and write down your 1, 8 times. You would write down your 2, 5 times. And then your 3 would be 6 times. So you would basically end up listing it all out. Now, okay, if you add up your column for the number of responses, this is coming out to be a total of 21. So 21 is not that big of a value. So yeah, you can go ahead and list it. But really, that's not a practical way of doing it, because, what if you had your frequency total in like hundreds or maybe even thousands? That wouldn't be very practical. So what you do in frequency distribution type of examples is go ahead and add your frequency column, get what your n value is going to be, how many total data values you have, and then use the position formula. So 21 plus 1 is 22. 22 divided by 2 will give us 11. So you are trying to find the 11th position, in your frequency distribution. Normally with frequency distribution, we always write, these numbers over here in order from smallest to largest. So technically, it's already arranged for us. So what you need to do is start adding up your frequency numbers. So start at the first. 2 plus 8 is 10. So we need to go to the 11th position, which means the 11th position will fall right here. And which means our median is going to be number 2. And you can see we're talking about the 11th number is 2. That means the median is going to be 2. If you count from the bottom, 6 plus 5 is also 11. So it still brings you to the same category of 2. So that's actually what you do when you're trying to find the median with frequency distribution, because trust me, you don't want to list, all your data values out. That's going to be long and tedious when you have a bigger data set. So those are our 2 calculations, mean and median. Now the third one we are looking at is mode. And mode, as I was telling you guys before, is the most frequent value that occurs in your data set. So the number that has the highest frequency, or what we sometimes in English call as your most typical value. So again, it's based on which occurs the most often. And so in this case, you're looking for the data point with the highest frequency. So if we go back to our candy example, looking at these 12 values, what would you say our mode should be? Which number has the highest frequency? So we've got 97 that occurs once, 101 which has 2 occurrences, 102 is also repeating twice, 103 repeats twice, 104, 105 is once, 107 is once, and then 108 repeats twice. So which numbers are occurring more often?
101, 102, 103, and 108.
Yeah, so those numbers occur twice while the rest of them occur only once. Very nice, Cynthia. So what happens with mode, guys, is you can actually have multiple modes, or what we call as a multimodal. Sometimes we have, unimodal, which means you only have one mode. Bimodal would be two modes, and then, multimodal, which is what this example is. You can have multiple modes in that. So like you guys said, 101, 102, 103, and then the last one, 108. So this would be multimodal. And if you look at this example over here where we just did the calculation for median, the 8B part, what would you say about the mode for this example? Which number has the highest frequency?
They all just occur once.
They all just occur once. Yeah. So there's no one number which occurs, two times or three times. So in this case, since none of them are occurring more than once, this is where we would actually say they have no mode, because, at least you should have one repetition on a number for it to be considered a mode. So since all of your numbers only occur once, this is an example of where we would say no mode. For that matter, even part A, if you look at that, there are no repetitions happening there. So even that one we would say has no mode on it. So you don't have to have a mode in all examples. Again, it will just depend from set to set what it would end up looking like. And they're kind of walking you through those examples over here. So you can see for part C, we're talking about bimodal because your number 9 repeats twice, number 3 repeats twice, but then the rest of them repeat only once. So that was bimodal. And that's kind of what happened in our example with the candy production. We had 4 numbers which were repeating twice and the rest of them only repeated once. So that was multimodal. You can see for part B, they are saying there's no mode because each number has the same frequency. So in this case, all of our numbers were actually repeating twice. So you don't even have where one number, just occurs once and the rest of them are twice. Each one of them occurs twice. So you can see there's 4 and 4, 9 and 9, 1 and 1, 10 and 10. So both, all the numbers are repeating twice. So again, there's no mode. And then of course, in the first example, your mode was 10 because 10 is repeating 3 times. You can see 5 repeats twice, 4, 1, and 8 only appear once. So 10 had 3 occurrences, which made it the highest frequency. So 10 is your mode. So again, just some basic examples here to kind of help you out with the, just to give you an example of how the 3 examples would look. And then, as I said, there's one more calculation, and even though your book doesn't talk about it, I want you guys to be familiar with it. So this is the mid-range. And remember, this is where you take your highest data value, add the lowest data value to it, and then divide it by 2. Sorry, not subtract. And divide it by 2. So of course, for our example, that would be the lowest data value is 97. We would add the largest, which is 108. Add them together, whatever that total comes out to be, divided by 2. And you can see this guy comes out to be 102.5. So if you look at all of these different average calculations that we did, I mean, they're pretty close to each other, right? You've got 103.4 if we keep it to 1 decimal place for the mean. We've got our median at 103. Your mode is going from, 101, 102, 103 to 108. And then our mid-range comes out to be 102.5. So you can see this was a pretty consistent data because all the numbers were so close to each other. That's why our mean, median, mode, and mid-range are, very close to each other. But sometimes you have data which is so spread out So, your numbers can go from, maybe 80s, 90s, all the way to maybe 150s. If you have a bigger spread, then in those cases, your mean, median, mode, and mid-range could actually come out to be quite different values. So it just really depends on what kind of data set you have, and are these four, average calculations going to be close together, or are they also going to be more spread out? So it just kind of depends on what kind of data set you have. So are you guys okay with these three calculations? Mid-range is not going to show up in homework or anything like that, since your textbook doesn't have it, but I do want you to be familiar with that calculation. Alrighty. Where were we? Okay, yeah. Another part that they are talking about here is just it helps to avoid any confusion or misunderstanding in situations in which the word average is used. And that's kind of what I was saying earlier. In the hands of someone with questionable intentions, numbers can be manipulated to mislead people. And statistics is definitely one of those places where it is very easy to manipulate the numbers. Like they said, if people have questionable intentions, then it can be, manipulated. So they're saying in the book by Daryl Huff, How to Lie with Statistics, the secret language of statistics, so appealing in a fact-minded culture, is employed to sensationalize, inflate, confuse, and oversimplify. So he's saying, statistical methods and statistical terms are necessary in reporting, the mass data for social and economic trends, business conditions, opinion polls, the census and stuff like that. And so they're saying readers who know what they mean, the result can only be semantic nonsense. But if somebody does not know what they're looking for, then, they can fall prey to these kind of sensationalized, reports. So they're saying an educated public should always be alert on the oversimplification of data via statistics. So the next time someone mentions average, you should ask, what kind of average, which calculation is being used? Because like I said, average is a very ambiguous word. Because it can have four different meanings, and each calculation can give you a different answer. And I think you guys will see that as you go through homework. They're not always going to be close to each other with those, well, in your case, three calculations, since they're not doing mid-range. But yeah, definitely a chance to do, some comparison in that case. So average is one thing we talk about, the measures of central tendency, but we then also need to talk about, how much our data is spread out. Because, and I think this example here might be highlighting that you can actually, for two different data sets, get the same mean, right? Get the same mean, and then different situations, median and mode also, but definitely you can get the same mean for two different data. So then you can't really do a comparison if two different data sets have the same mean. So in that case, we bring this idea of dispersion, or sometimes we call it variation, or just think of it as how spread out your data is. So if you look at this example over here, we're talking about, to settle an argument over who was the better bowler, George and Danny agreed to bowl, 6 games, and whoever has the highest average would be considered the best. Kind of like, the example they asked us in last section, who is the best professional football player, kind of thing. So, they go ahead and do their 6 games. And as you can see, once we calculate their averages, the mean and median and mode for George, the mean and median and mode for Danny, and you can see this is coming out to be 185, 185. That's the mean for both of them. The median is also coming out to be 185, and their mode is also coming out to be 185. So basically 185 for all 6 values over here. So, again, they can settle their argument because they said, okay, whoever has the highest average would be considered the best. Well, they both got the same average. But if you look at their scores from those 6 games, you know, George had 185, but Danny had 182. There's a big difference over here, 135, 185. This is 200, 188, you know, 250 and 180. That's a significant difference there. And then 155 and 190. This is where they had the same score. So you can see, you know, they did score a little bit differently. And, you know, obviously they are decent players because they're, you know, pretty consistent in their scores. But then you can see we kind of had the 200, 250 coming from George, and Danny kind of stayed in that 180 to 190 range. But when we did the calculations for mean, median, mode, they had the same value. So this is kind of where, you know, we're talking about sometimes just looking at the average is not enough. You need to start looking at spread, or, you know, start looking at dispersion, which is what we're actually going to be doing with, I believe, yeah, with these two guys over here to see, you know, who ends up being a better bowler. So dispersion is going to be our next calculation, and measures of dispersion include range. And we actually talked about range when we were doing our frequency distribution last time. So we have our range, variation, and standard deviation. And standard deviation is definitely kind of like, you know, the flagship measurement that we use when we talk about dispersion. So that's what we'll get into next time, guys. So we'll pick up with section 4.3. So at this point, like I said, as far as your homework goes, you guys should be able to work on 4.1 and 4.2 sections. So for those of you who have yet to start, please get started. I really don't want to see any of you falling behind and not being able to take your exam. So if you have any questions, let me know. And if not, then I will see you guys on Monday morning. So have a wonderful weekend, guys. Be safe. Enjoy. Bye, everyone. Yeah.